Hello everyone, my name is Karan Mashru. Welcome to this video. And in this video, we are going to look at the efficient solution of the problem which we discussed in the video 2.26 of this series. So I hope आपने 2.26 वाला video देखा है. Okay, and this video number is 2.27. So basically, we want to find the maximum value of j minus I such that a of j is greater than equal to a of I, where the array a is given with n elements. और इसका ब्रूट फोर्स अप्रोच हमने क्या देखा था, दैट वी विल आइटरेट ओवर ऑल द पेयर ऑफ एलिमेंट्स एंड वेन एवर ए ऑफ जे इज ग्रेटर देन इक्वल टू ए ऑफ आई वी विल से आंसर इज इक्वल टू मैक्स ऑफ आंसर कॉमा जे माइनस आई. ठीक है, सो दिस वॉज गोइंग इन टू एन स्क्वेयर अमाउंट एंड वी वॉन्ट टू फाइंड इट एफिशिएंटली. Now understand one thing, why here it is going into n square amount of time, because we are iterating over all the possible pairs. If we want to find the efficient solution, so somehow we will have to reduce the number of pairs through which we iterate and compare. जैसे कि यहाँ पे सारी n square pairs को हम iterate करके compare कर रहे हैं, so we need to reduce that somehow. Are you getting my point? So we need to somehow reduce the number of pairs which we iterate and compare, so overall our time complexity will decrease. Okay, so we need to use some logic and decrease the number of pairs which we compare. Okay, so let's look at this example and let's think how we can decrease the number of pairs which we compare. So let's say we have one answer variable which will be, let's say, initialized to 1 because 0, because minimum 0 तो आंसर होगा ही होगा. I want to find the maximum value of j minus I such that a of j is greater than equal to a of I. So even if I make I equal to j, then a of j will be equal to a of I because I is equal to j, in which case j minus I would be 0. Okay, so I'll initialize my answer with 0, and now let's say I start with I here. Okay, now first of all, for j I will only look on the right hand side. Okay, because I want to find the maximum value of j minus I. So if j is less than I, it will become negative value, right? So my j I want to find on the right hand side. Now tell me, what is the best value of index j for this I, where I is pointing to 0th index, such that I get the maximum value of this and a of j is greater than equal to a of I. मतलब कि मुझे एक ऐसी j की वैल्यू चाहिए जो एज राइट एज पॉसिबल हो, ताकि j माइनस आई की वैल्यू मुझे एज मैक्सिमम एज पॉसिबल मिले, एंड a of j must be greater than equal to a of I. Okay, so I'll start my j from here. Okay, now there is one concept like how we will implement this efficiently, but we'll come to that. Okay, so हमें पता है कि इसके राइट हैंड साइड पे यहाँ पे है 12, right? This is the rightmost value. See, it does not necessarily be the largest value. Are you getting my point, what I'm trying to say? For example, this may be 13. So this is also greater than 9, and this is the rightmost value. So if my j will be here, then j minus I will be maximum for this 9. Are you getting my point? So it does not necessarily be that this a of j is the largest value on the right hand side of 9. जैसे कि ये 12 है, ये 13 है, but which is farther is this 12. So this will yield j minus I maximum. Are you getting my point? So my let's say my j is here. Okay, so j minus I value will be what? This is 0 1 2 3 4. So 4 minus 0 would be 4. So my answer will become 4. For this I, this j is the best. ठीक है, now I'll move here and try to find the value for this I. Now try to understand one thing. Even if there is any value with respect to this I which is greater than a of I, which is here, there is no point of iterating here. Why? Because जब हमारा I यहाँ पे था तो rightmost value we got here. So this much j minus I value we already have in the answer. Are you getting my point? Now if I move my I here, so there is no point starting j again from here or from here, because even if this a of j is greater than a of I, let's suppose for example 13 is greater than 8. So even if this a of j is greater than a of I, this j minus I will be definitely less than this j minus I. तो हमारा j अगर इस I के लिए ये राइट मोस्ट वैल्यू है, देन फॉर दिस I विल ओनली ट्राई टू फाइंड द वैल्यू ऑफ j ऑन द राइट ऑफ दिस, which gives me the value greater than equal to 8. There is no point finding here. Are you getting my point? For example, ये मान लो हमारा a of I था और इसके लिए rightmost value जो as right as possible है and it is greater than equal to this a of I, वो यहाँ पे है. So for this value I, the best j minus I value is this much distance. Now if my I comes here, then why should I keep my travel my j here, here? Because this distance of j minus I will be definitely less than this. So I will only look for j at this position and on the right of it, which yields the value a of j greater than equal to a of I for this. Because only indexes on the right of this j can have distance more than this. There is no point when I is here traversing j here. So for this I, if this was the rightmost j where a of j is greater than equal to a of I, I'll continue my j from here only to find the best j for this. I'll not traverse again from here. This is how I'll reduce the number of comparisons and hence decrease the time complexity. Okay. So let's continue understanding. So now if my I is here, my j can be here because 12 is greater than equal to 8. But now there is no, now if I take my j here, now there is no element which is greater than equal to 8 here. Okay, so now I will not get any j which is greater, which has value greater than equal to a of I. Okay, so what should I do before moving j? I should move I now further. Are you getting my point? Because it might be possible. See, since there is no j on the right hand side which is greater than equal to a of 8, there is no meaning taking my a of j till here. Because what if there was some I for which there was some j here and it gave me a of j greater than equal to a of I and this distance as answer. Right? So I should not skip all these j values without any reason for this 8. जबकि 8 के लिए तो कोई यहाँ पे उससे greater than equal to value है ही नहीं. Are you getting my point? So instead of moving j, I should move I and try to find a of I such that this a of j is greater than equal to that a of I. Are you getting my point? So that's the overall idea. Okay. So I hope you have got the crux of the problem, like what I am trying to approach. Now there are one or two questions which we need to answer, and then what we will do is we will club all these concepts and directly move on to the implementation. Now, when my I is here, how will I know that what is the rightmost index j where a of j is greater than equal to a of I? So I will start my j from here only, but I will keep on moving it right until I get an element which is greater than equal to a of I. So on the right hand side of this we have an element, so I'll move j here. On the right hand side of this we have an element, so I'll move j here. We have on the right hand side, so I'll move j here. Now when I'll move j here, now there is no element which is greater than equal to a of I, so I'll stop here. Okay. Now how can we know in efficient manner whether there is any element on the right hand side? So if my current index j is somewhere here, how can I know efficiently whether there is any element on the right hand side which is greater than equal to a of I? Efficiently, how can I know? I can know it via suffix max. If I can maintain a suffix max array, then the suffix max value at this index j will give me the maximum value in this suffix from j till n minus 1. So if the suffix max at j is greater than equal to a of I, it means either index j or some index on the right hand side is exist whose value is greater than equal to a of I. Now you should have the knowledge of suffix max. I am not going to tell it right now. Okay. So now what I will do is, let me club the whole concept and dry run it for you. So I will have 9, then 8, then 7, 13, 12, 5, 7, 13, 12, 5, then 4, 1, 2, 4, 1, 2, 4, 0, 0, 3, 4, 0, 0, 3. Okay. So my I is here. Now I want suffix max array. So I would say suffix max. अगर आपको नहीं पता तो arrays की playlist में आगे मैंने पढ़ाया है prefix max, suffix sum, ठीक है, तो प्रीफिक्स मैक्स एरे आएगा इसका 3 3 3 4 4 4 4 5 12 13 13 13 13, ठीक है. Now I'll start my j from here only. You can also start it from I plus 1. It doesn't matter. My answer value is 0. ठीक है. Now if suffix max of j is greater than equal to a of I, it means there is some value of j at this index or on the right hand side, because अगर यहाँ पे suffix max की value 13 है, it does not mean कि original array में भी इसी index पे 13 है. It means कि 13 यहाँ पे है या तो right में कहीं पे है. But from this index till end the maximum value is 13. Now it can be anywhere here. Okay. But since suffix max of j is greater than equal to a of I, it means for this I there is some j value on the right hand side or this index itself where a of j is greater than equal to a of I. Okay, because this 13 value is somewhere na, so this is definitely greater than this, right? So but now you will say, but 12 is the best value for this I. This index j is the best because this j minus I is maximum. We'll come to that. As we'll dry run, you'll understand it. If suffix max of j is greater than equal to a of I, it means there is some index j here or on the right hand side whose value is 13, which is greater than equal to 9. Okay, now it may be here, 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 we do not know. This suffix max 13 denotes that the maximum value in this range is 13. Okay, so we'll assume that it is at this index only, let's suppose. Then in that case, what will be j minus I value? 0. So my answer will be 0. And I'll do j plus plus. Why? Because this 13 may also lie on the right hand side somewhere. It is actually lying here, right? So if it is lying somewhere on the right, then again I'll get suffix max of j greater than equal to a of I. Are you getting my point? So I'll keep on moving j to the right hand side until suffix max of j is greater than equal to a of I, and I'll keep storing j minus I in the answer variable if it is greater than the answer stored till now. So again, suffix max of j is greater than equal to a of I, so j minus I is 1. Now my answer will become 1, and I'll do j plus plus because this 13 may lie here or may lie here. I do not know, or somewhere on the right. When I say j minus I is 1, I have assumed that this 13 is here. And so this is a of j, this is a of I, and a of j is greater than equal to a of I. I have assumed that 13 is here, but it may be on the right hand side as well because this is suffix max. Now my j came here. Again, suffix max of j is greater than equal to a of I. So now j minus I will be 2, and I'll do j plus plus. Again, suffix max of j is greater than equal to a of I. So I'll do answer equal to 3, and I'll do j plus plus. Because if you keep on doing j plus plus, तो ये 13 जो है वो actually जहाँ पे stored होगा, है ना, राइट हैंड साइड पे, वहाँ तक तो suffix max 13 ही आएगा, तो वहाँ तक तो आपका j चला ही जाएगा. And you'll ultimately calculate j minus I, where j is pointing to the index where originally you have 13 and I to the index where you originally have 9, जो कि हमने calculate कर लिया है 3. Now j came here, so again suffix max of j is greater than equal to a of I. यहाँ पे suffix max 13 था, it means there is some value on the right hand side which is greater than equal to 9. यहाँ पे suffix max 12 है, इसका मतलब including this index and on the right hand side there is some value, there is at some index there is the value 12 which is greater than equal to 9. It may be here or it may be on the right hand side. For example, अगर यहाँ पे 12 होता तो भी suffix max यहाँ का 12 ही होता ना, we do not know. So again, suffix max of j is greater than equal to a of I, so j minus I now will be 4. I'll store 4 in the answer and I'll do j plus plus. Now suffix max of j is 5, which is less than a of I. It means what? This suffix max 5 denotes that from here till here the maximum value is 5. So now here there is no index j such that a of j is greater than equal to 9. So there is no meaning comparing this 9 with any of the indexes here. So I'll do I plus plus. So if suffix max of j is less than a of I, then I'll do I plus plus. Now again, suffix max of j is 5, a of I is 8. So again I'll do I plus plus. But one very good thing to note is, for 9, the rightmost index was this 12 value. Okay, this was the maximum j minus I value which we stored as 4, and then my j moved here. Now when my I moved to 8, I didn't start my j again from 7, 13, 12 and so on, as I showed you in the concept in the beginning, because these distances with this I and j here, they will be definitely, that j minus I will be definitely less than 4. So I'll keep j here and move forward only. But again, suffix max of j is less than a of I, so I'll move I plus plus, because there is no index whose value is greater than equal to 8 on the right, so I should take my I forward. Again, suffix max of j is less than a of I, so again I'll do I plus plus. Again, suffix max of j is less than a of I, so I'll do I plus plus. Suffix max of j is less than a of I, so I'll do I plus plus. Now suffix max of j is greater than equal to a of I, so I'll do j minus I, which is 0, so I should not store 0 because 4 is greater than 0, but now I'll do j plus plus. Now suffix max of j is less than a of I, so I'll do I plus plus. Suffix max of j is greater than equal to a of I, j minus I is 0, so answer will not be updated, and I'll do j plus plus. Suffix max of j is greater than equal to a of I, so j minus I is 1, so I'll not update the answer value, and I'll do j plus plus. Suffix max of j is greater than equal to a of I, j minus I is equal to 2, I'll not update the answer variable. Suffix max of j is greater than equal to a of I, so j minus I value is 3, I'll not update the answer variable. Now suffix max of j is less than a of I, so I'll do I plus plus. Suffix max of j is greater than equal to a of I, difference is how much? 3, so I'll not update the answer. Suffix max of j is greater than a of I, distance j minus I is 4, so answer variable will not be updated, I'll do j plus plus. Suffix max of j is greater than equal to a of I, now the difference is j minus I is how much? 1, 2, 3, 4, 5. So now answer will be updated to 5, because here you have 3 and here you have 1, and you'll do j plus plus, but there is no j now going forward. So as soon as you reach out of bounds, you should stop, and this is your answer variable. Okay, and I hope you understood how we saved a lot of iterations, because when my 9 was my I was here and my j reached here, when my I came here, I didn't start my j again from here. Okay, तो ओवरऑल टाइम कॉम्प्लेक्सिटी कितनी होगी? एक आइट्रेशन I का होगा एंड एक आइट्रेशन j का होगा. So overall time complexity would be big of 2n, which is equal to big of n only. And auxiliary space कितनी होगी? ये भी big of n होगी because of the suffix max array. ठीक है? So let's implement it. Okay. So I'll take a new file. What should I name it as? Array question, or let me name it as 2.27. Okay, because in that way I'll find it. So include IO stream using namespace AI is on int main. Okay, so let me write a bit of code with AI. So I'll take the value of n. Okay, now I want suffix max, okay, of size n. Okay, no, this is not correct. I'll name it as suffix max, then AI will understand. Okay, yeah, now suffix max of n minus 1 is a of n minus 1, and for I equal to n minus 2 to 0, suffix max of I is max of a of I and suffix max of I plus 1. अगर आपको suffix max के बारे में नहीं पता, we are not going to discuss in detail in this class. Okay, अब हमें क्या करना है? So now I'll basically stop the AI. Okay, so I will say answer equal to 0, and my I will start from 0 and j will also start from 0, and while j is less than n, because j पहले खत्म हो जाएगा. Okay, so I'll keep the condition on j. Okay, so if a of I is less than equal to suffix max of j, then I would say answer is equal to max of answer comma j minus I, and I would do j plus plus, else I would do I plus plus. So there will be one iteration on I and one iteration on j. Okay, and finally I'll print the answer value. Okay, so clang plus plus 2.27.cpp /a.out, एंड नंबर ऑफ एलिमेंट्स हमें देने हैं, तो इसी एरे को दे देते हैं 13 एलिमेंट्स है. Okay, and now the elements value 9 8 7 13 12, 9 8 7 13 12, 5 4 1 2 4, 5 4 1 2 4, 5 4 1 2 4 0 0 3 0 0 3. ठीक है ना. तो आंसर आ गया 5. यहाँ पे हमने 13 एलिमेंट्स ही दिए थे ना, 1 2 3 4 5 6 7 8 9 10 11 12 एंड 13, एंड आंसर आ गया 5 जो कि एक्सपेक्टेड है. ठीक है. So this is about the implementation of this question, that is finding the maximum value of j minus I from an array such that a of j is greater than equal to a of I in an efficient manner of big of n. I hope आपको इस वीडियो में सब कुछ समझ में आया होगा. थैंक यू.